In this video, I want to take a look at, in ascending order of difficulty, possible derivative problems you might encounter on your Calculus 1 and 2 journey. As you might have guessed, we'll be starting with the easiest derivative, the derivative of e to the x, which quite simply is equal to e to the x. Of course, there's a proof behind this, but we don't have to get into that for this video. For level 2, let's tackle another two basic rules actually of differentiation, the power rule and sum and difference rule. So we have this polynomial, and we will do the power rule for each term. So 3 times 4 times x to the 3 minus 1 plus 2 times 3 times x to the first plus 1 times 19 times x to the 0. So it'll equal 12x squared plus 6x plus 19. Pretty easy. For level 3, let's step it up, and we will do the quotient rule. So for this problem, I want to start out by taking out that constant 1 over 8 term. This will simplify the denominator when we apply that later on. So then we take the derivative using the rule. I'll just rewrite it a bit lower. So 1 over 8 times the derivative of the top function, which is 2, times the regular bottom one, which is x to the third, minus the regular top function times the derivative of the bottom, which is 3x squared. And then this is all divided by the regular bottom function, the original squared. I will simplify this now. Distribute the terms. This is over x to the 6th. And when we bring back the 8, it looks like we can take out the 4x squared. And it'll reduce quite a bit. So this will equal negative x minus 3 over 2x to the 4th. Now we're stepping into level 4 territory, where we have the chain rule with some trig derivatives. So let's define our two functions, our f of x and our g of x. And 3x to the minus 3 minus e to the x, and then we'll define our f prime and g prime functions. This will be negative sine x, and g prime of x will equal negative 9x to the minus 4th minus e to the x. Now we'll be taking the f prime of the g of x function times the g prime of x. So this will be the negative sine of 3x to the minus 3rd minus e to the x times the g prime of x, so negative 9 x to the negative 4th minus e to the x. And we can't do much to simplify here, so we'll just rearrange it to put the negatives on the bottom. So it'll be minus sine, and should x to the 3rd, minus of course, times 9 over x to the 4th. Alright, pretty easy. But level 5, we will step it up. You'll recognize for much of differential, it's just applying these rules in longer formats. But for level 5, here we have natural log, and we're applying the chain rule twice. You start by just taking the derivative of that natural log with that whole inner function. So it'll be 1 over all of that times the derivative of that inner function. And right away we can just take out this constant 2 and just find the derivative of the square root of x squared plus 1. So applying the power rule, basically the square root of x squared plus 1 will be 1/2 times x squared plus 1 to the negative 1/2 power. And then we want to multiply that by the derivative of that inner function, applying the chain rule a second time. So it's times 2 to the x. And now we can put everything together. 2 times 1/2 times x squared plus 1 to the negative 1/2 times 2x over all of that original stuff. And looks like there's quite a bit to simplify. We can take out this, it's on the top and bottom. And we have 2 times 1/2 we can take out. And it looks like it's just x over x squared plus 1. Pretty easy for level 5, you might think. Not too bad. Level 6, on the other hand, damn near impossible. But for level 6, we'll be entering implicit differentiation. So now we just have to take it step by step and find the derivative of both sides of this equation. So we'll apply the sum and difference rule first. Put our operator everywhere just to keep it organized. It starts with the derivative of cosine squared x. Now this will just be, in a sense, applying the power rule. So it'll be cosine x squared, this whole thing, times 2 to the first power. And then this will be times the derivative of the inside, which is negative sine x. So we'll rewrite that whole thing as negative 2 cosine x sine x. And we'll do the same thing with the y, negative 2 cosine y sine y. But now we have to add that dy over dx. And this is what we're looking for, of course. Here we're going to apply the chain rule again. So it'll be negative sine times the what's already there in the inner function, or negative sine of, rather. And then this will be multiplied by the derivative of that inner function. And again, we have to put that dy over dx whenever we're differentiating the y term. Now we want the dy over dx on the same side so we can isolate it. So what we can do first is multiply it out on this right hand side, distributing our terms. And now I'll rewrite this left hand side to put them both on the same side. So we're adding the minus 2 cosine y sine y to both sides. So we'll have 2 dy over dx sine of 2x plus 2y minus 2 dy over dx times cosine y sine y. And this will be equal to all those right hand expressions. And there we go. Now to get it by itself, I will isolate it by just dividing that left-hand side by dy over dx. So at the end, we'll just be dividing the the right-hand side by the left-hand side, and then dy over dx will be by itself. So dy over dx times 2 sine 2x plus 2y minus 2 cosine y sine y, and this is equal to that whole right hand side. Not much room here, I'm gonna have to erase quite a bit. So now when we divide, we'll also be able to simplify the 2's, but it will be equal to the negative 2 sine of 2x plus 2y plus 2 cosine x sine x all over 2 sine 2x plus 2y minus 2 cosine y sine y. And to get it in its simplest possible form, we'll take away all these two terms, and we have our answer. Now for level 7, we'll be doing implicit differentiation again, but now with hyperbolic trig functions, and we'll include some exponentials there. So e to the xy minus e to the xy squared equals the tanh of y. Now this is another chain rule application. So we want e to the xy, which is, its own derivative, times the derivative of what it's doing. So it's just x times dy over dx plus y. The product rule is there. And we can do the same thing with the other one. Two xy dy over dx plus y squared. And now we want the derivative of the tanh of x, or tanh of y in this case. And that is just equal to 1 over the sech squared of y. And then, of course, we want the chain rule applied there, so we'll be multiplying times dy over dx. Now we want to again bring these dy over dx terms on the same side, but to do it faster, we'll actually just do it directly from where they are in their expressions. So it's being multiplied by x times e to the xy if you were to distribute. And then here it's being multiplied by negative 2xy times e to the xy squared. And then here it would come to the left side, so we'll just do minus here. And it'll be minus sech squared y. And this is equal to, if we were to multiply the other terms, distribute the other terms, e to the xy times y. And that would have come to the other side, so that'll be minus. So minus y times e to the xy. This will be plus, because it's going that side, so y squared, e to the xy squared. And then we'll just be dividing both sides by this huge expression. So dy over dx will equal minus y times e to the xy plus y squared e to the xy squared over x times e to the xy minus 2xy e to the xy squared minus sech squared y. Now that was definitely long, but I don't know if it was super difficult. Hopefully not too challenging for level 7. We of course have level 8. We'll step away from implicit differentiation. It's pretty much the same as you move along. And we'll do something a bit more interesting, you probably might not have seen before in your differential journey thus far. We'll even use a rainbow color. So we have this exponential function, 3x to the 4x. Now we have to follow this rule, a to the b power is equal to e to the b natural log of a. And first we can just take out that constant 3, so we're finding the derivative of e to the 4x natural log x. Now here it probably looks quite familiar, so you can solve this normally. The chain rule will be applied. So it's e to the 4x natural log x times the derivative of that power. Now we want this derivative, which will be equal to, we'll use the product rule to find it. So it'll be 4 times natural log of x plus the 4x times 1 over x, which will just be 4. So this will equal 4 natural log x plus 4. You can see how I eliminated it there. So now we can do quite a bit of rearranging. Not quite a bit, actually very little. It's just 3 times e to the 4x ln x times the derivative we found here, and we'll take the 4 out actually, so it's 4 times natural log x plus 1. And now we can simplify. It'll be, well, I'll combine the 3 and 4. It's 12. This we can bring back to our a to the b term, a to the b expression rather. So this will just be x to the 4x. So we have 12 times x to the 4x. And then this will be multiplied by natural log of x plus 1. Oh yes, that was definitely quite interesting for a level 8. For our final stage 9 derivative, we'll be doing the hyperbolic arc derivative, and we'll throw in a complex expression there just to mix it up. So first things first, the derivative of an arc coth function is 1 over 1 minus x squared. So we're just applying the chain rule first. And that'll mean we do 1 over 1 minus this whole inner function squared, e to the x times 3i plus 9. And then this is times the derivative of that function. Now here we're applying the chain rule again. So it'll be e to all of this times the derivative of what it's being raised to. So this equals e to the 3i plus 9 times x times. Now for the derivative of this complex expression, there's actually a different rule you can follow. I'll link in the description how it's derived, where when you take the derivative of e to that expression times x, it will simply be equal to that expression times e to the expression times x. So in a sense, you don't even have to apply the chain rule. This equation here, formula, whatever you want to call it, automatically does it. So we'll just write that. And this will all be over what we've already written, and then we'll have our answer. So this is over 1 minus 3 to the, or e to the 3i plus 9 times x. So in a sense, we didn't really have to do much complex analysis. It's just a rather simple formula we need to follow. And if we distribute the 2, this will be our answer. I didn't want to get too much into complex variable algebra for this video, as we're only doing with calculus 1 and 2 material. In general, differential calculus is easier than all these other branches of calculus, like partial derivatives or integration or differential equations. So, hope you enjoyed, hope you subscribe, and I will see you in the next video.